Pull up a chair, will you? Let me show you the view from the captain's seat. From vintage cockpits with steam gauges to today's glowing glass panels, the magic of flight remains. The aircraft's electrical and electronic systems are its nervous system, powering everything from wingtip lights to autopilot. Grab your logbook and let's explore the heart of modern flight together. The electrical system is the heart of the aircraft, powering lights, engines and essential functions. The electronic systems are the brains, processing information, guiding navigation and enabling communication. Understanding both is vital. In the air, you manage these systems, turning potential emergencies into manageable situations. This knowledge builds confidence, keeps you safe, and is your best co-pilot on every flight. Every great journey begins with a single step. And for an aircraft, that first step is a spark. The battery is the heart of the plane, providing the initial jolt of energy to start the engine and power essential systems. Flip the master switch and the aircraft wakes up. Lights flicker, radios crackle and instruments come alive. In an emergency, the battery is your lifeline, powering critical systems so you're never left in the dark. A healthy battery is a cornerstone of safe flight, guarding you against the unexpected. Once the engine is running, the alternator or generator in older aircraft takes over as the electrical powerhouse. Like a bicycle dynamo, it converts engine motion into electricity, recharging the battery and powering all onboard systems. Modern aircraft use alternators because they're lighter, more efficient and work even at low RPM. Always monitor your ammeter, it's your window into the health of your electrical system. So we have the battery providing the initial spark and the alternator generating continuous power. But how does that electricity get from the source to all the different things that need it? It doesn't just flow randomly through the aircraft. It's channeled and distributed in a very organized way through something called an electrical bus or bus bar. You can think of the bus bar as a central power strip or a junction box for the entire airplane. It's a solid metal bar where the main power wire from the alternator and battery connects, and from which all the individual electrical circuits branch out. This central distribution point is incredibly important for managing the aircraft's electrical system. Instead of having a chaotic mess of wires running directly from the power source to every single light, radio and instrument, you have one main feed going to the bus bar. Then, individual wires run from the bus bar to each component, each protected by its own circuit breaker or fuse. This makes the system neat, tidy, and much easier to troubleshoot. If a specific component, like the landing light, stops working, you know the problem is likely in that one circuit, not the entire electrical system. It isolates faults and keeps one problem from taking everything down. In the cockpit, you interact with the bus bar through a row of switches and circuit breakers. Each switch allows you to turn a specific system on or off, completing or breaking its connection to the bus. The circuit breakers are your safety devices. If a system tries to draw too much current, perhaps due to a short circuit, the breaker will pop, automatically cutting off power to that circuit to prevent overheating and a potential fire. As a pilot, you learn where every breaker is and what it controls. A popped breaker is a signal that something is wrong, and you need to investigate it carefully before deciding whether to reset it. This organized system of distribution provides redundancy and safety. Many larger aircraft have multiple bus bars, such as an essential bus for critical flight instruments and a non-essential bus for things like cabin lighting. In an emergency, like an alternator failure, you can shed the load from the non-essential bus to conserve battery power for the systems you absolutely need to fly the plane safely. This ability to manage your power distribution is a fundamental skill. It transforms you from a passenger along for the ride into a true systems manager in complete control of the energy that powers your journey through the sky. With the alternator powering the bus bar, let's see how electricity travels through the aircraft. Wires act as the vanes, channeling power from the bus bar to each component. Lights, radios, instruments, each on its own dedicated circuit. A circuit is a complete loop power source, protective device, switch, load and a return path. Often the airframe itself saving weight and complexity. This separation means a problem in one circuit, like a wingtip light, won't affect your flight instruments. If a device fails, think, is the switch on? Is the breaker in? Trace the circuit logically to troubleshoot. Understanding these paths is key to keeping your aircraft systems running safely. Electricity is powerful, but if uncontrolled, it's dangerous. A short circuit, like a wire touching the airframe, can cause a surge, risking fire or damage. Fuses and circuit breakers protect against this. A fuse melts and breaks the circuit if current is too high. A breaker pops out and can be reset. Most modern aircraft use resettable breakers, but only reset once after a pause. Never force it. A popped breaker is a warning, not a nuisance. Always ask, what does this circuit power? Is it essential? Why did it trip? These guardians keep you and your aircraft safe. Respect their signals. Once flying a Cessna 210, my autopilot breaker popped mid-flight. I took manual control, stabilized the plane, and assessed the situation. Autopilot isn't critical, so I could continue safely. After a couple of minutes, I reset the breaker. It held, and the autopilot worked for the rest of the flight. The lesson: a popped breaker is information, not an emergency. If it trips again, leave it out and have it checked on the ground. Know your systems, follow procedures, and always fly the airplane first. The breaker did its job, and so did I. The master switch is your electrical command center. Turning it on brings the aircraft to life, off puts it to sleep. Usually split into BAT and ELT, it lets you control battery and alternator power separately. In emergencies, you can isolate a failed alternator or shut down all power to fight an electrical fire. Knowing how to operate the master switch by feel is critical. It's your first and last line of defense for electrical control. Mastery of this switch is essential for every pilot. Aircraft lights serve two main purposes, being seen and seeing. Navigation and anti-collision lights, red, green, white and strobes, make you visible and help prevent collisions. Landing and taxi lights help you see the runway and taxiways and make you visible to others. Each light has a dedicated switch, drawing power from the bus. Procedures become habit: beacon on before engine start, nav lights at night, landing lights for takeoff and landing. These lights are more than bulbs, they're vital safety tools. Every switch you flip is a step in the choreography of safe flight. Section 2. The electric eyes powering the instruments. The electrical system powers your cockpit's vital instruments, your electric eyes and ears. From classic fuel and oil gauges to modern digital displays, electricity keeps you informed. Electrically driven gyros replaced fragile vacuum systems, making flights safer and more reliable. If the alternator fails, you're on battery power, so every switch matters. Your instruments are your window to reality. Without electricity, you're flying blind. Communication radios are the pilot's voice to the world, connecting you to air traffic control, weather briefers and fellow pilots. Powered by the aircraft's electrical system, these radios turn your words into radio waves, keeping the skies safe and organized. Mastering radio use is as vital as flying itself, transforming anxiety into confidence and making modern flight possible. Navigation radios let you listen to ground-based aids, guiding you even when you can't see outside. VOR stations act like electronic lighthouses, letting you track your position and fly precise routes. For landings, the ILS system provides exact guidance to the runway. All these systems depend on your aircraft's electrical power. Without it, you lose your primary means of navigation. For decades, the standard aircraft cockpit was a sea of round individual gauges, what we affectionately call steam gauges. You had one for airspeed, one for altitude, one for heading, and so on, spread across the panel. It was a reliable system, but it required the pilot to constantly scan across a wide area, gathering bits of information from each separate instrument and mentally piecing them together. This constant scanning was a learned skill, a visual dance that every pilot had to master. While effective, it demanded a lot of your attention that could sometimes be better spent looking outside or thinking ahead about the flight. Then came the revolution, a change as profound as the shift from propellers to jets. We called it the glass cockpit. The individual mechanical gauges were replaced by large glowing computer screens. These screens, known as flight displays, could show all the traditional flight information and much more, all in one consolidated, easy-to-read format. The primary flight display, or PFD, combines your airspeed, attitude, altitude, vertical speed and heading information into one elegant presentation. Suddenly that frantic visual scan was replaced by a focused gaze on a single screen that told you everything you needed to know about the aircraft's current state of flight. Alongside the PFD, another screen appeared, the multifunction display, or MFD. This screen is the true genius of the glass cockpit. It's a versatile, customizable map that can display your route, real-time weather from satellite or ground-based radar, surrounding air traffic, terrain warnings, and detailed information about your engine and other aircraft systems. All that data that used to be on separate charts on your lap or in your head was now overlaid on a single dynamic map. It was like going from a simple paper roadmap to a live interactive satellite navigation system in your car, a monumental leap in situational awareness. This transition wasn't just about pretty screens, it was a fundamental shift in how pilots interact with their aircraft. These displays are the face of incredibly powerful computers running sophisticated software, all powered by the same electrical system we've been discussing. They take raw data from sensors all over the aircraft, air data computers, GPS receivers, magnetometers, and process it into intuitive graphical information. This allows the pilot to absorb complex information much more quickly, reducing workload and freeing up mental capacity to make better decisions. The glass cockpit truly represents the brains of the modern bird, a smart electronic co-pilot that helps us fly safer and more efficiently than ever before. The autopilot is one of the cockpit's most misunderstood tools. Many imagine pilots just relaxing while a robot flies, but in reality, autopilot is a precise assistant, not a replacement. It follows pilot instructions, making constant, smooth corrections using data from flight instruments. The pilot remains in charge, always monitoring and guiding the system. Used wisely, autopilot makes flying safer and less demanding. For decades, navigating through the skies involved meticulously tracking signals from ground-based VOR stations, a method that confined us to flying along established airways, much like cars on a highway system. It was effective, but not always efficient. Then came a technology that changed everything: the Global Positioning System, or GPS. This satellite-based system, powered by the clockwork physics of orbiting satellites and the aircraft's electrical system, gave pilots a tool of almost unbelievable accuracy. It was like suddenly being able to see our own position on a map, from space, anywhere on the planet, at any time. An aircraft's GPS receiver is a small electronic box that listens for the faint signals broadcast by a constellation of at least 24 satellites orbiting high above the Earth. Each satellite transmits its precise position and the exact time of the transmission. By receiving signals from at least 4 of these satellites, the GPS receiver in your cockpit can perform a series of complex calculations to triangulate its own position, its latitude, longitude and altitude, with remarkable precision. This information is then displayed on your MFD or a dedicated GPS unit, showing your aircraft as a little icon moving across a detailed map. The impact of GPS on aviation cannot be overstated. It allowed for the creation of direct-to navigation. Instead of zigzagging from one VOR station to another, a pilot could now simply tell the GPS the destination airport, and the system would draw a straight line, the most efficient route possible, directly to it. This saved time, fuel, and reduced congestion on the old airways. It also opened up vast areas of the world that had no VOR coverage, allowing for safe and reliable navigation over oceans, deserts, and mountain ranges, where pilots previously relied on older, less precise methods of navigation. Furthermore, GPS paved the way for highly accurate instrument approaches known as RNAV, or area navigation approaches. These GPS-guided procedures allow pilots to fly precise paths down to landing at thousands of airports that could never afford the expensive ground equipment required for an ILS. This has dramatically improved safety and accessibility for general aviation, giving pilots a safe way to get into smaller airports in poor weather. This all-seeing eye, powered by satellites in space and the electronics in our panel, has given us the freedom to navigate the skies with a level of confidence and precision our predecessors could only dream of. In the most advanced aircraft we find the maestro that conducts this entire orchestra of electronic systems, the Flight Management System, or FMS. The FMS is the pinnacle of aircraft automation, a powerful computer that integrates nearly all of the electronic components we've discussed. It combines the navigation capabilities of GPS and VOR, the control authority of the autopilot, and a vast database of flight information into a single cohesive system. It is the central brain that allows a pilot to plan and execute an entire flight, from takeoff to touchdown, with an incredible degree of precision and automation. Before a flight, the pilot programs the FMS with the complete flight plan. This includes the departure airport, the route with all its waypoints, the destination airport, and even the specific arrival and approach procedures. The FMS also takes in performance data like the aircraft's weight and the planned cruising altitude. With all this information, the FMS calculates the optimal flight profile, including climb speeds, cruise speeds, and descent points. It can even predict fuel consumption with remarkable accuracy, telling you exactly how much fuel you'll have when you arrive at your destination. It is a master planner for the entire journey. Once airborne, the FMS truly comes to life. When coupled with the autopilot, it can fly the entire programmed route automatically. It will guide the aircraft along the lateral path, turning from waypoint to waypoint, and in many systems it will also manage the vertical path, automatically controlling the throttles and pitch to climb, cruise and descend according to the pre-programmed profile. The pilot's role shifts from being a hands-on manipulator of the controls to a high-level manager, monitoring the FMS and the autopilot, ensuring they are performing as expected and intervening if any deviations or unforeseen circumstances arise. This sophisticated integration of systems is what makes modern long-haul flight possible and exceptionally safe. The FMS is a symphony of electronics where the GPS provides the position, the autopilot provides the muscle, and the FMS itself provides the intelligence to bring it all together. It is the ultimate expression of the brains of the bird. But even with this incredible technology, the human pilot remains indispensable. The FMS can only do what it is told. It is the pilot's knowledge, judgment, and experience that programs the system, monitors its performance, and ultimately remains in command, ready to take over when the unexpected happens. Flying a Piper Cherokee 6 over rural Texas on a moonless night, the cockpit panel suddenly flickered. My heart skipped a beat. The ammeter showed the battery was discharging. Classic alternator failure. I calmly worked the checklist, shut off non-essential lights and reassured my passengers. With just enough battery, I found the nearest airport, declared an emergency and landed safely. That night, I learned the value of training and staying calm under pressure. Flying a Cirrus SR-22, I was surrounded by advanced glass cockpit displays until suddenly my primary flight display went black. Instantly, all my vital flight info vanished. Training kicked in. I switched to backup gauges, took manual control and landed safely. It was a powerful reminder. Technology is great, but knowing your basics and backup systems is essential. From the spark of a battery to the symphony of a flight management system, we've seen how electricity and electronics are the heartbeat and brains of flight. My hope is that this journey has demystified these systems for you. The sky is a vast classroom, and the best pilots never stop learning. Embrace curiosity, study your aircraft, and seek wisdom from mentors. The horizon of learning in aviation is truly endless, and that pursuit is its own reward. Flying is a privilege, a dance with physics and technology that gives you a unique view of the world. With this privilege comes responsibility. Be diligent, prepared, and safe. The sky is waiting. Go out there, fly safely, and never stop learning. Your journey as a knowledgeable aviator starts now.